Hey everyone, and welcome back to the channel. Today, we're venturing 93 million miles away to investigate a cosmic mystery that's happening right now on the surface of our very own star. We all know the sun. It's the life-giving heart of our solar system, a seemingly constant and steady ball of fire in the sky. But what if I told you that our star isn't just burning? What if I told you it's also shaking, rattling, and rolling in ways that have scientists completely baffled? That's right, we're talking about sunquakes. Now, when you hear the word earthquake, you probably picture the ground shaking, buildings swaying, and tectonic plates grinding against each other. It's a powerful destructive force, born from the solid rock beneath our feet. But the sun, well, the sun isn't solid. It's a colossal ball of superheated gas and plasma, a turbulent, chaotic ocean of fire. So how on the sun can it have a quake? It's a fantastic question, and the answer is absolutely mind-blowing. Sunquakes are real. They are gigantic seismic events that send ripples, like the ones you see when you drop a stone into a pond, hurtling across the sun's surface. These aren't small ripples either. We're talking about waves that can be several miles high, traveling at incredible speeds of up to 25,000 miles per hour, and spreading across vast distances. Imagine a tsunami of pure plasma, an oceanic wave of fire, and you're getting close to the sheer scale of a sunquake. So how do we even know this is happening? We can't exactly place a seismometer on the sun's scorching surface. This discovery is a testament to the power of modern solar observatories, like NASA's Solar Dynamics Observatory, or SDO. These incredible telescopes stare at the sun 24/7, capturing images in different wavelengths of light that reveal the hidden dynamics of our star. Using a technique called heliosomology, basically, the study of the sun's vibrations, scientists can observe these ripples expanding outwards from a central point. It's like seeing the sun's surface ring like a bell, and it's one of the most astonishing phenomena in our solar system. These sunquakes were first spotted back in the late 1990s, and ever since, they've presented a profound puzzle. The biggest question of all is, what causes them? What could possibly have enough power to strike the sun's surface with such force that it generates these colossal seismic waves? For a long time, the most popular suspect was something you've probably heard of: solar flares. Solar flares are among the most violent events in the solar system. They are sudden, intense bursts of radiation and energy that erupt from the sun's surface. We see them as brilliant flashes of light. It seemed logical, right? A huge explosion happens on the surface of flare end. That explosion sends shockwaves rippling outwards, creating a sunquake. For years, scientists observed a strong correlation. Where there was a powerful solar flare, a sunquake often followed. It was a neat and tidy explanation. The flare erupts, it slams energy down onto the solar surface, and boom, sunquaked. It was the leading theory, and it made perfect sense. Case closed. Or so we thought. As our observational tools got better and we collected more and more data, a few cracks started to appear in this theory. Scientists began to notice some very strange things. For one, the sunquakes often seem to originate from a point slightly different from the brightest part of the solar flare. Even stranger, sometimes the sunquake would begin before the main, visible eruption of the flare even happened. Think about that. It's like hearing thunder before you see the lightning. It just doesn't fit the cause and effect relationship we expected. The impact can't happen before the thing causing the impact. This led to an even more perplexing discovery. Scientists looked deeper, and I mean that literally. They used helioseismic holography, a fascinating technique that allows them to peer beneath the visible surface of the sun, much like an ultrasound lets us see inside the human body, and what they found turned the whole mystery on its head. In many cases, the source of the sunquake wasn't on the surface at all. It was lurking deep below, about 700 miles under the photosphere, the visible surface we see. That's a huge distance to be inside the sun. This was a game changer. If the source is deep inside, then the solar flare happening up on the surface can't be the direct cause. Instead, it seems both the flare and the sunquake might be symptoms of the same, much deeper, and much more mysterious phenomenon. So, what could this hidden trigger be? This is where we enter the cutting edge of solar physics, and scientists are exploring some truly wild ideas. One of the leading hypotheses now is that there's some kind of submerged, powerful magnetic event happening deep within the sun's interior. Let's back up for a second. The sun is ruled by magnetism. Its powerful, tangled magnetic field lines are what drive almost all of its activity, from sunspots to solar flares. The idea is that deep beneath the surface, these magnetic fields can become twisted and unstable. They might snap and reconnect in a violent event called magnetic reconnection. This submerged explosion could be what generates the acoustic energy, the sound waves that travel upwards, hit the surface, and create the sunquake ripples we observe. According to this model, this deep explosion also sends a jet of energy rocketing upwards towards the surface. When this jet breaks through, it triggers the solar flare we see. So, in this scenario, the flare isn't the cause of the quake. Instead, a single, powerful, underground event is the common trigger for both the quake below and the flare above. The deep acoustic blast creates the sunquake, and the upward moving energy blast creates the flare. This would explain why the quake can sometimes start before the flare is fully visible. The sound waves from the deep event reach the surface first. But this is still a theory, and it comes with its own set of puzzles. We don't fully understand the physics of what's happening in that turbulent region 700 miles below the surface. What could cause the magnetic fields there to destabilize so catastrophically? Is it a sudden collapse of a magnetic structure? A chain reaction? We just don't know yet. It's like trying to understand what's happening at the bottom of the ocean by only looking at the waves on the surface. We can make educated guesses, but we can't see the whole picture. And here's another twist to the story. Not all solar flares produce sunquakes. In fact, most don't. Only a small fraction of even the most powerful X-class flares are associated with these seismic events. Why? What makes one flare a quaker and another a dud? This suggests that there's a special ingredient, a specific set of conditions deep inside the sun that must be met for a sunquake to be born. Figuring out what that secret ingredient is one of the biggest challenges for solar physicists today. Solving this mystery isn't just an academic exercise. Understanding sunquakes is fundamental to understanding our star. If they are indeed triggered by deep, submerged magnetic explosions, then they give us a brand new window into the sun's invisible interior. They could be a diagnostic tool, a way for us to probe the complex magnetic engine that drives everything the sun does, and that engine has a direct impact on us here on Earth. The same magnetic forces that might be triggering sunquakes are also responsible for space weather, the solar flares and coronal mass ejections that can hurl enormous clouds of charged particles towards our planet. These solar storms can disrupt our satellites, knock out power grids, and pose a risk to astronauts in space. By understanding the root causes of these events, by deciphering the warnings that sunquakes might be giving us about what's brewing deep inside, we might be able to improve our ability to forecast this dangerous space weather. It's about predicting the sun's temper before it erupts. So, the next time you look up at the sun safely, of course, with proper protection, remember that it's not just a serene, glowing orb. It's a dynamic, complex, and sometimes violent place. It's a star that trembles and shakes, ringing with the echoes of mysterious explosions happening deep within its fiery heart. The mystery of sunquakes reminds us that even with our most advanced technology, the universe is still full of secrets, and our closest star might be holding the biggest ones of all. What do you think is causing these incredible seismic events? Let me know your theories down in the comments. Thanks so much for joining me on this journey into the heart of the sun. If you enjoyed this deep dive into cosmic mysteries, please hit that like button, and be sure to subscribe and ring the bell so you don't miss our next adventure. Until next time, stay curious.